Here's something wild: most of the videos you watch, the songs you stream, the AI responses you get in seconds, they're all traveling through cables buried under the ocean floor. And right now, they are straining to keep up with demand. Global data cables are hitting a breaking point. We are talking about a data traffic tsunami that only gets worse as AI explodes and billions of people come online. Microsoft, Meta, Nvidia, and Google have just come together on something completely unprecedented: a subsea tunnel called Rogfast. This isn't just another fiber optic cable, it's a brand new kind of infrastructure that could break every underwater speed record in existence. We're not talking about incremental improvements here. This tunnel could deliver data 2 to 3 times faster than anything we've got right now. That alone would be huge. But here's where it gets interesting. Pair that with a completely redesigned breed of flexible, modular data centers that can adapt in real time to wherever demand actually spikes, and you're looking at a fundamental reshaping of how the internet works. In the next 10 minutes, you'll see how this hidden infrastructure battle is reshaping global tech, who's winning the race, and why it matters way more than most people realize. Think of the internet as a massive global nervous system, and subsea cables are the backbone. Around 99% of all international data, that's your emails, your Netflix streams, your cloud backups, everything that crosses an ocean, travels through these fiber optic pipes buried on the ocean floor. They are kind of like the arteries of the planet. Here's what most people don't realize: these cables are old. The infrastructure that powers the modern internet was built in the 1990s and 2000s. We've been adding new ones, sure, but they've all followed basically the same design pattern. Single cables per route, single point of failure, limited capacity. As data demand exploded, AI training, cloud computing, billions of video streams per day, we hit a hard wall. The cables just can't keep up. Latency increases, speeds drop, and certain regions of the world get starved for bandwidth because the cables connecting them to major data hubs are completely saturated. This creates this weird situation where a country might have fantastic internal internet, but the moment data needs to leave the country or come in from outside, it gets bottlenecked hard. Video quality drops, responses get sluggish. That's the fundamental problem Rogfast is trying to solve by completely reimagining how data crosses the ocean. So what's Rogfast exactly? It's not just one cable, it's a completely new architecture. Instead of a single pipe carrying data, Rogfast uses a multi-route system that sends data across multiple paths simultaneously. Think of it like upgrading from a single-lane highway to a superhighway with 8 lanes all running in parallel. The technology behind it builds on something called spatial division multiplexing. Basically, they've figured out how to squeeze more data through the same fiber by using different dimensions of light, different polarizations, different wavelengths, all packed into one cable. The result? The tunnel can handle data rates that are literally double or triple what legacy cables can do. We are talking about petabits per second. That's 1 billion gigabits for those keeping score at home. But here's where it gets really clever. This isn't just about speed. Rogfast is designed to be redundant. If one path fails, data automatically reroutes. That means more reliability, less downtime, less chance of the whole internet choking if a ship's anchor damages a cable. And get this, the tunnel actually connects Norway to the United Kingdom, strategically positioned to handle data flows between Europe and North America. It's not random. Every part of this system was engineered for maximum efficiency. Let's talk about who's actually building this and why they care so much. Microsoft, Meta, Google, and Nvidia are all contributing capital and expertise. Why? Because they are literally drowning in data. Google's serving search results across the planet. Meta's streaming video to billions of people. Microsoft's running Azure data centers on every continent. Nvidia's training massive AI models that need massive compute. All of them depend on subsea cables to move data between their data centers, and they're all seeing the same problem. The cables are the bottleneck. Rogfast gives them what they need: more capacity, less latency, more reliability. It's especially important for AI because training models at scale requires moving terabytes of data constantly between regions. A single millisecond of extra latency can add hours to a training run. So when you're talking about models that take weeks to train and cost millions of dollars, faster cables aren't nice to have, they're absolutely essential. The tunnel is also strategically important. It connects Norway to the United Kingdom, which means it funnels data between Europe's data centers and the rest of the world with minimal delay. That makes European AI companies more competitive, makes cloud services faster for European customers. It's a game changer for the companies building the AI future. Here's the thing about old subsea cables: they've been the standard for decades and they work, but they're starting to show their age. A typical modern cable can handle maybe 3 to 5 petabits per second. Rogfast, 10 petabits per second minimum. That's not incremental improvement, that's a paradigm change. But it's not just speed. Existing cables are point-to-point. One cable runs from point A to point B, period. If that cable gets damaged, you're in trouble. Ship's anchor damage happens more often than you think. There's a damaged cable somewhere in the ocean roughly every 3 days on average. Rogfast, on the other hand, is designed with redundancy built in. Multiple routes, multiple failover paths. If one section gets damaged, data automatically reroutes through another path with minimal disruption. It's like comparing a single-lane road to a multi-lane highway with alternative routes. You also can't ignore the power efficiency angle. These old cables require massive amounts of power to amplify signals as they travel thousands of miles. Rogfast uses newer technology that's significantly more power efficient per bit transmitted. For the big tech companies, that saves millions of dollars in operational costs per year. And when you're running dozens of undersea cables around the world, those savings add up fast. Now let's zoom out. What does Rogfast actually mean for you and the rest of the planet? First, the obvious: faster internet between continents. Streaming video will be faster, cloud services will be snappier, international video calls will have less lag. That's nice, but it's not revolutionary for most of us. Our internet is already pretty fast if you live in a developed country. But here's where it gets interesting. Rogfast also means cheaper global infrastructure. When tech companies have more reliable, faster cables, they don't need to build as many redundant systems. That saves money. And eventually, some of that savings could get passed to consumers in the form of cheaper cloud services, cheaper internet, cheaper everything that relies on international data transfer. But the bigger story is about global equity. Right now, if you live in Africa, South America, or Southeast Asia, your internet quality depends heavily on how many cables service your region. More cables mean more competition, more capacity, more choices. Rogfast is just one cable, but it's a proof of concept. It shows that this kind of advanced infrastructure is possible. It might inspire governments and companies in less connected regions to invest in their own subsea cables. And that could genuinely change the global divide in internet access and speed. Internet access is increasingly a determinant of economic opportunity. A kid in Nigeria with fast internet can compete globally. Without it, they are isolated. Rogfast is a small step toward a more connected world. Okay, so we've talked about the cables. Now let's talk about what's happening on land: flexible data centers. This is the other big piece of the story. Traditional data centers are massive, fixed installations. A big building full of servers in a specific location. You build one, it stays there for 10, 20 years. But the new flexible approach is different. Instead of one giant data center, companies are building smaller, modular data centers that can be deployed rapidly wherever demand spikes. Think of them like Lego blocks instead of a giant concrete building. You need more capacity in Europe. You can spin up a new modular data center in weeks, not years. You need to handle a sudden surge in AI traffic. Deploy a small, self-contained facility specifically for that workload. The benefits are huge. First, it's way faster to deploy. Second, it's more efficient. Instead of running a massive facility at partial capacity, you scale up gradually. Third, it gives tech companies flexibility to respond to where customers actually are, not where they guessed customers would be 5 years ago. And here's the kicker: paired with Rogfast's high-speed, reliable connectivity, these modular centers can work together seamlessly. Data can flow freely between them without bottlenecks. It's a complete rethinking of internet infrastructure for the AI age. So here's what this all means for you and the future of technology. Rogfast and flexible data centers represent a fundamental change in how the internet actually works. Instead of an old, rigid, vulnerable infrastructure held together by 30-year-old cables, we're moving towards something faster, more reliable, and far more resilient. For most of us watching right now, this translates into better internet experiences, faster streaming, snappier cloud services, lower latency on video calls. But the deeper impact is about AI infrastructure. Tech companies can finally scale AI and cloud services at the speed innovation requires. They can compete globally without being bottlenecked by aging cables. And here's what matters. Countries and regions that invest in modern subsea cables and modular data centers will have a genuine competitive advantage in the AI decade ahead. Infrastructure might seem boring, but it determines who wins and who loses in technology. Right now, companies like Microsoft, Google, and Meta are building the foundation for the next era of AI. Subsea cables like Rogfast aren't glamorous, but they are increasingly the real limiting factor. Every new cable that comes online is a signal that someone is serious about AI infrastructure. That's where to watch the real innovation happening. Follow for more deep dives into the infrastructure reshaping AI and technology.